Hey everyone, welcome back to the channel. I am Suyash and this is the fifth video in our series Base 64 encoding the must know use cases. Today we are diving into something really useful and really practical is how to store binary data like PDFs or images inside a database that doesn't natively support binary fields. We'll be using MongoDB, which is a NoSQL database, unlike traditional relational databases like MySQL. MongoDB stores data as flexible JSON like documents, which is perfect for the scenarios where you data structure often changes or when you have different things to store quickly without worrying about rigid schemas. I'll explain the basics of NoSQL databases, how MongoDB compares to relational databases, and why might you be needing or choosing MongoDB over MySQL in certain projects. Then we'll jump to hands-on tutorial where we'll encode a file into base64, store it in safely in MongoDB, and retrieve it back for our application. So without further ado, let's get started. So let us understand NoSQL databases first. NoSQL is not just SQL or not only SQL databases. So they actually store data in anything but relational way. So these databases actually emerge to address the limitations of SQL databases when handling large volumes of unstructured data. So also these bases actually represent a paradigm shift in data storage. So why NoSQL matters is because they handle massive volumes of structured, semi-structured, and unstructured data efficiently. They also provide flexible schema design, so that which can be made to adapt as application requirements evolve over time, and they come with horizontal scaling rather than vertical scaling, so reducing infrastructure costs. So they also deliver high performance for read and write operations at scale. Now, if NoSQL databases do not make use of SQL, how do they actually query for CRUD operations? So there are actually different types of querying mechanisms in NoSQL databases. First one is the document storage. This is made. This is actually used to store in JSON like documents. So the entire database can be exported in JSON or CSV format. MongoDB and CouchDB use these kind of flexible schemas with nested structures, and the querying mechanism is using various query languages just as JSON or JavaScript. Then comes the key value stores. So these are simple model pairing the unique keys with values. So Redis and DynamoDB are actually the example of this kind of storage. And then comes the column family stores. So in this query mechanism, the data is stored or organized into column families. So Cassandra and HBase handle this kind of query. So in family stores query using column oriented operations for analytical workloads. Then comes the graph databases. As the name suggests, these store entities and relationships as nodes and edges. So Neo4j and ArangoDB are one example of this. Let's now compare SQL databases and NoSQL databases. So the most important difference or most peculiar difference about SQL and NoSQL databases is structure. So in SQL databases, you have a fixed schema with predefined tables, columns, and relationships, and data must conform to strict structures before insertion. Whereas NoSQL database allow dynamic schema, so it means flexible and evolving data models. So each document is flexible. Fields can vary from one document to another, unlike rigid relational databases. In terms of scaling, vertical scaling is possible in case of SQL databases, which means adding more power to existing servers, whereas horizontal scaling is complex and expensive when SQL databases are concerned. In NoSQL databases, horizontal scaling is always possible, which means adding more servers, and it is designed for distributed architectures and cloud deployments. The common use cases for SQL databases are your financial systems, your ERP applications, traditional business applications, whereas for NoSQL databases are real-time analytics, content management, IoT applications, social networks, and high velocity data processing. Let's talk about MongoDB itself, which we are going to be using in our project. So MongoDB is a NoSQL database, which means instead of rigid tables and rows, it stores data as flexible JSON-like documents. This makes development faster and more intuitive, especially for modern applications built with JavaScript, Python, or other object-oriented languages. At the core of MongoDB are collections and documents. Collections are like tables in relational databases, but without enforcing a strict schema. They group related documents together. Documents are the individual records stored in BSON format, each with a unique ID field that acts as a primary key. Collections are created automatically when you insert your first document, though you can define them explicitly with rules or options. Now, MongoDB offers two important tools that serve different purposes. First one is the MongoDB Compass. So, it is basically a graphical user interface that you can install locally. It lets you visualize and explore your MongoDB data, create and modify documents, and run complex queries. It is ideal for developers and database administrators working with local databases. Compass also provides features like schema analysis, index management, and data visualization. On the other hand, when we talk about the other tool that it provides, so MongoDB Atlas is a fully managed cloud database service. It takes care of scaling, backups, security, and even global distribution for you. Atlas is designed for organizations and developers who want a production ready cloud based solution without worrying about infrastructure. It offers automated backups, monitoring, encryption, and access control. So the key differences are straightforward. Compass is installed locally while Atlas runs in the cloud. Atlas is built for scalability and robust security, while Compass is focused on local database management and exploration. Now, talking more about Atlas, so Atlas even offers a free tier called the M0 cluster. This gives you 512 MBs of storage, shared RAM and CPU, and limited bandwidth. It's perfect for learning, experimenting on small scale applications. You can deploy one free cluster per project, which makes it a great starting point for beginners. So, to summarize, Compass is your local GUI working with MongoDB, while Atlas is your cloud based, fully managed database service. Together, they give you flexibility to learn, prototype, and scale your applications depending on your needs. So to start, I would require a dependency for MongoDB for Spring Boot application. So I'll have to go to Spring Initializer to get that dependency. So inside the dependencies, I'll go to add and I'll type in MongoDB. So here and you have to support Spring Data MongoDB. Uh, and when you click on explore, you will find out that this is the dependency for Spring Boot Starter Data MongoDB. And this is the one that we want. So I'm going to just quickly copy these dependency for test and for this as well. And then I'm going to head back to my Spring Boot application and add it there. So I'll open up the pom.xml file and I'm going to add it over here. I'll just paste it. Once I have pasted this, I'll just do the load Maven changes or Maven reload. This is going to take a bit of time to actually resolve the dependencies that we have added. Once we are in complete sync, I'll head over to the application.properties file and I'm going to add uh, two more configuration. First, the configuration for MongoDB and then I'll add the configuration for multipart. Since we really want to have the upload functionality, and we want that we want a particular binary file like a PDF or an image to be uploaded using a API. So we have to add some multi-part config over here. First, for MongoDB, I'm going to add the property, and here and I'm going to type in spring dot data dot not data source data MongoDB database, not database actually. I'm going to type in URI. So MongoDB URI, as it was being suggested, I have to add in this connection string as MongoDB / localhost, and the port for MongoDB default is 27017 / and I'm going to name the collection as base 64 underscore use cases. This is going to be perfect for MongoDB configuration. Now coming to the multipart, we actually want to increase the multipart max file size. So I'm going to add spring.servlet multipart max request size, not request size, max file size. So this is going to be about 5 MB. And then after that, I'm going to also add spring.servlet multipart max request size. I am not seeing this, so I'm going to, yeah, max request size, that is perfect. So this is going to be also 5 MBs. So since I've added these, I'm going to just save this file now. And we have added the configuration for MongoDB, but this collection doesn't exist yet. So I'm going to just copy this name and head over to MongoDB Compass. So I'm going to just open this and I'm going to create a database, and I'm going to name this as base64 use case, and I'm going to give the same name for the collection as well, and I'm going to click on create database. So inside this database, I think I have made one mistake over here. I should have named the collection as assets, because that is what I'm going to save here. I can actually add another collection over here, so I'm going to add that instead of removing the existing collection that we have created. So I have created another collection yet. So this is done from here as well. So we will head back to the ID again. So now the configuration for MongoDB connection and the collection is also created. So we should head to creating one entity for our for mapping our database to this. So I'm going to just head over to the models package. I think we haven't yet created any model or entity for any other use cases. So this seems like the first package inside the models package. So inside this, I'm going to create a Java class, and I'm going to call it as stored assets. Okay, so I'm going to add it over here. Now inside this, I'm going to add a few fields. First, I'm going to add in private string ID. Then let me just copy this again, since I have to write the same thing and I have to add another string. So this, instead of ID, it will be the file name, and it will contain the name of the file. After this, there will be a MIME type. It will determine what type of data we are storing, whether it is basically an image or a PDF or whatever. So this is going to be the base64 data, or the base64 string, which will be we will be getting after converting the binary files. And then we'll also be taking one timestamp over here. So in MongoDB, timestamps are actually have a type of instant. So I'm going to add it there. I think that is the import. So I'm going to call this field as created add. And then what I need to do is I need to add an @ID annotation for on the field ID. Also, I actually have forgotten to add the annotation of @document on the top of this class. and I'm going to call it as assets. I think the spelling over there is wrong, so I'm going to actually correct it later on. But now, since we have created the class and we have declared all the fields, what we need to do is we need to add some getter, setters, and constructors. So I'm going to use IntelliJ IDEA for this, and I'm going to first select none for a non-parameterized constructor or a default constructor, and then I'm going to choose all the fields to generate a parameterized constructor. Then we need the getters and setters. So I'm going to use again the IDE for this. So I'm going to select them all and just going to create these getters and setters for myself. So this file is pretty much complete now. We have the entity created. Now what we need to do is we need to create one repository for this entity. So I think we have the repository layer for package over here. Okay, we do not have the repository package, so I'm going to create a repository package first to keep things organized. Repository I have added. Then inside this package, I'm going to add another package, and I'm going to call it as use case 5. And inside the use case 5 package, I'm going to create an interface, because repositories are basically interfaces. I'm going to call this as stored assets repository. Once this interface is created, I'm going to actually this interface is going to actually extend the Mongo repository. So this Mongo repository will be having the stored asset entity that we created along with the string value. Since the ID is of type string, so we are passing the type as string. So this is done. Now inside this repository, I'm going to have one method proposed. So this will be of type list. Okay, I think there was wrong import. This will be of type list. I think there is some import issue going on. Yeah, this first one I need. So this list will also be of type stored assets. Then this method, I'm going to call it as find by MIME type. So this method, as the name suggests, is basically going to give us a particular list of stored assets by the type or by the MIME type. Like for example, if I choose application slash PDF, that means it is going to return us all the PDFs. So I'm going to pass the string as MIME type over here. So the repository layer is also created. We should now head back to creating the service that is going to implement various logic to actually decode and handle the incoming file. So inside the services package, there is a use case 5 package that I have already added over there. So I'm going to create a file inside this, and I'm going to call it as asset storage service. And this service is going to be having the dependency for the repository. So asset storage, I think I'm storage assets repository, correct. So we have the dependency for storage asset repository, and I'm going to call this object as repository. Now we need to actually inject this dependency now. So for that, I'm going to use a simple constructor injection. So I'm going to add the final keyword over here, and then I'm going to ask the ID again to generate a constructor, and hence the constructor injection will be made. So after this, I'm going to create some methods. So first I'm going to create a method called store, and okay, and this method is basically going to store and store an uploaded file and an optional file name override, then store it as base64. So this method is going to have a few parameters in the signature. So first is the multipart file, and I'm going to create the object as file. Then it will also have string override name as parameters, and this should return the object of stored asset. So let's add that over here. So inside this method, first we are going to have a few checks. First one to determine if the file is empty. So check if file empty. Then the second check should be for if the file size is too large. So check if file is too large. This is going to be another of our checks. And third check we are going to put over here to determine if the file type is allowed or not. So check if MIME type is allowed. MIME type is so first check for file empty. We are going to just write an if statement, and I'm going to check if file is empty using this is empty method. And if this is so, we are going to throw a new illegal argument exception. And we need to pass a string message over here. So we are going to pass simply that file is empty. Okay, then afterwards, so it is showing me an error over here. Let's check what's the matter over here. So we haven't added the exception to the method signature. So let us have IntelliJ handle that out. So it has handled the method signature, but instead of illegal access exception that we have added incorrectly, we should actually add the illegal argument exception. And let me just clear this out. Okay, this is okay. And now instead of this throw illegal access exception, let us just add IO exception. So after this check is complete, we need to check if the file is too large to process. So we're going to add another if statement and file dot get size. I think there is a method, yes, for get size. If that get size is greater than 5 MB, so 5 MB should be written as so. If that is the case, let us throw new illegal argument exception, and we are going to pass a message as file too large. And let us actually specify that this file is larger than 5 MBs. So let me close this. And the third check to see if the MIME type is allowed. So I'm going to quickly create a string for this, and I'm going to call it as MIME, and I'm going to use the file dot get content type method. And this will be getting the type of the content, and we are going to now place the check if is allowed MIME, and we are going to pass this MIME string that we just created to this method. If that is the case, we are going to throw another exception. So throw new illegal argument exception, and this will have the message as unsupported type. Then we are going to pass MIME string. So this is also done. Now we haven't yet created this is allowed MIME method. So we are going to create this inside this as well. So we are going to get to the implementation of this later. We are going to continue building our logic and get back to this afterwards. So so we have kept all the checks. Now it is time to actually store the file as the method is supposed to do. So down below, I'm going to actually take in the string file name equal to I'm going to first also check if override name is not null, and we are going to also check another condition, that is override name dot is blank. Okay, so this will be for checking is if it is blank. We have to check if it is not blank. So I'm going to add the exclamation for negation. Then if this is the case, then we are going to use the ternary operator to actually have it set down as override name. Otherwise, we are going to actually use the class file name. I think this is the utility class, but I'm not sure about the name that we have to use. I think it is called the file name utils. I think there is going to be an error over here. It cannot resolve the symbol. So let me just check it once. Well, I'm trying to add the import statement manually, but I think there is some other problem with this file name utils class. We have to check if this is the part of JDK or do we need another library for this. So let me just check this once. So I think I need to add this dependency for comments/io. So we can actually choose to not include this version, but let us check if this works. So I'm going to just do a quick Maven reload again so that the added dependencies are resolved quickly. And once these are resolved, I think there is no problem with the sync. Let us go back to our service layer and check if everything went okay. I think there is an, okay, I think I have added the excess capital. So this is going to be there. Let us improve this. I think the Maven reload didn't work the last time. Yeah, now it works. So where is the error that is shown? Expected. Okay, I got it. So we can continue from where we left off. So file name dot get name. So inside this get name, what I'm going to do is I'm going to get the name of the file. So file dot get original file name. That is the method that we are going to call. Now, after that, I'm going to just close it. So here, what we are basically doing is we're trying to get the name of the file, and we are first checking if the file is if the name provided is null or if the file is blank. So we are checking that first. So after this, let me just enter this to make it more organized. So that is our logic. Now, after this, what we are going to do is we are going to create an object of stored assets, and I'm going to call it as asset, and then initialize it again. So in this asset object, what I'm going to do is I'm going to set the file name as the file name that we have gotten from the user, and then I'm going to also set the MIME type as the MIME type that was sent to us. Again, I'm going to also set base64 data as base64. Okay, I think we did not name it as base64 in the entity. So let us check. Okay, it is named as base64 data. It's still giving me an error. Let me check what is going wrong. So I actually forgot to add this base64 string. So let me just create a new string for base64. Let's not create, okay, base64. And now we are going to add the utility package for base64 and call the method for get encoder dot encode to string, and I'm going to pass in the file object and then call the method as get bytes. So this will be giving us a base64 string by encoding, and now I'm going to use this base64 string to set to the asset object. And after that, one more thing that we need to do is that asset dot set created at. This is the last part that we have to do. So I'm going to call the instant dot now method that comes from java.time package. So we have added that as well. Now the only thing that we need to do is to return this repository dot save method. and we are going to pass this asset object and save it in the database. So that is done. I think there is a missing return statement. Okay, so we have until now created this method to the store the base64 string and the entire entry as the asset. So now we are going to complete this method that we created to check if the MIME type that is passed by the user is among the uh, allowed MIME types. So inside this method, what we need to do is to return simply the MIME, but we are going to check if it is not null, and if the MIME dot equals to application slash PDF. So first we have entered a check for PDF that is valid as well. Then we are going to add multiple MIME files over here. So let me just enter it and keep it in another line. Okay. So I'm going to add the OR operator and the MIME dot equals to image slash PNG. So we can actually upload a PNG image as well. Then I'm going to just copy this quickly so that we don't have to type again and again. And I'm going to change the format of the PNG to JPEG in this one. And after that, again, I'm going to add another image type. This is going to be image slash SVG, which is the basic for icons and other vector graphics. So this looks fine. I just need to close this. Okay, this is done. Now what is missing is that we need to add a few more methods, which I'll be adding quickly, and I'll explain them later. So this first method is going to optionally return the object of stored assets, and we are going to call it as get method. Okay, I think I made a mistake in this inside. I need to pass the string ID in the parameter, and this is going to return the object of repository dot find by ID, and this ID will be passed inside this. I think this needs to be removed for now. Now after this, I am going to also add public string to data URI stored assets asset to return the type data asset dot get MIME, sorry, not base64 but MIME type method plus base64 plus asset dot get base64 data. So I think I made a mistake. Okay, this comma is not going to be outside but inside. Yeah, so this is done as well. There is one just more method that I need to create. First, it's going to be public, and this is going to be returning a byte array, and we are going to call it as decode. This is going to decode the string for us. Stored assets asset, and inside it we are going to just return the base64 dot get decoder dot decode, and inside this asset dot get base64 data we are going to pass. So this one was pretty much self-explanatory, so I don't need to explain it again. The remaining two methods, let me just tell you what these are for. But first, I see there is one unintentional mistake that I've made. This method is going to be called as get and not get whatever that was suggested. So let me just save it first. So what this get method does is that it fetches a stored asset by ID, as we are calling the repository and then using the method for, and it delegates to the repository. So it returns optional type. So callers can handle the not found themselves at the repository level itself. And then for the method to data URI, we are building a data URI string for inline previews. So the return data plus mime plus base 64, it concatenates the proper data URI syntax that we should use. The browser can render this in the iframe/image tags without external files. So in the controller layer, I first of all want the dependency for asset storage service, and I'll be adding that. So since I'm going to use constructor injection, let's just add final to it. Then I'm going to make use of the IDE to actually take care of this. Okay, this is done. For some reason, it is not auto-wiring this for me. So let us try to remove this and then adding auto-wired annotation. I think this is an import issue. So let me just try to refresh this. Okay, we will come back to this later. First, let us write the code. So I'm going to create a method and it will be returning the type string with, I'm going to call it as list. We are going to pass an object of the model since this is an MVC controller, and model dot get attribute, and inside this get attribute we are using service dot get. Let me check the name of the method that they created. Okay, so this is list all assets. So we are going to add this and then we are going to return the view. Okay, we have to add the annotation get mapping and we are going to give the path as assets. So this endpoint that we created is going to handle get request to this slash assets. This is basically your list all assets page, and the model dot get add attribute, it adds all the stored assets to the model so that TimeLeaf can render them in a table. Next, we are going to add another endpoint. So let me just copy this entire thing first. We'll make changes to it as we go. So this is going to be for the uploading. So I'm going to call it as upload form. And this is not going to do this model and this, all of this. Let us remove this. This is not even going to take the model as parameter. This is just going to return the upload, and we are also going to change the, actually let's add to this as slash upload. Okay, this is also done. So this is basically the upload form endpoint. So it is going to handle the get request to slash assets slash upload. It shows the upload form and it returns the assets upload. It is going to return the upload from form template. Okay, now it is time to actually create the upload handler. So I'm going to add post mapping and we are going to keep it as assets only. Now the name for this method is going to be upload, and inside this I'm going to pass in as parameter a request parameter, and this is going to be file, and this is going to be type multipart file, and I'm going to name the object as file itself. Then let's add another request parameter, and this will have the value as file name, since we need the name of the file that we are uploading, and we are going to keep required as false. Then it will actually have be of type string, and we are going to keep the same name as file name. Then we are going to use the redirect attributes, and this is okay. So the method signature is done. Now what we are going to do is we are going to call an object of stored assets, and we are going to call the object of service and use the method store and pass in the file comma file name as we have declared it before. I think we have, okay, this error I'll have to check once. Okay, since this is a valid error actually, because the store is going to throw an exception. So I'm going to add an exception to the method signature as well using the ID feature. And after this, what we are going to do is we are going to return the redirect assets asset.get ID. I think, okay, I need to put an end over here, and then we have to concatenate this asset.get ID. I think we have used another variable. Okay, we have resolved the error. This needs to go. And instead of actually adding the throws IO exception over here, what we can do is we can also like put these statements inside a try catch block. So I'm going to cut it right now, and I'm going to put them into the try block. And after this, I'm going to add the catch for a generalized exception object. And inside the catch block, I'm going to use the redirect dot add flash attribute, and inside this we are going to pass the message or attribute value as error, and we are going to also add e dot get message to get the complete log of what went wrong. Then we are going to return the redirect slash asset slash upload. Okay, this is done. Then to sum up, what we have done is we have created an upload handler, and this is going to be of type post. So it basically handles all post requests when the user submits the upload form. The parameters we have taken as file. This is going to be a multipart file. Then we have taken another as file name, which is optional override file name for us. Then we have created an object for redirect attributes redirect. So it basically allows passing flash messages after a redirect. And the try block is actually calling the service.store to validate, encode, and save the file as in the service layer. And then after that, it adds a success message with redirect dot add flash attribute. So it redirects to a detail page of the newly uploaded asset. And then the catch block, if something goes wrong, file too large or unsupported file type, adds an error message and redirects back to the upload form. And then we are going to create yet another endpoint over here. This will be of type get mapping, and I'm going to name the path as assets slash. This will be taking a query variable or a query parameter. So this method is going to be named as public string detail and I'm going to add the path variable, or path variable will be of string type, and I'll name it as ID. Let's actually put the other things in the next line. So I'm going to delete the model object and redirect attributes, redirect. Then inside it, it's going to do just one thing. It's going to return service dot get id dot map. So let me put this in the next line, dot map. So asset stored. Okay, it should not be. Let me remove this asset. This should open over here. Then model dot add attributes. I should close it over here. Okay, I think I have. Yeah, that is some mistake. Okay, so now I just have to copy this line and add it below. Now instead of asset, I'm going to pass in the data URI, and I'm going to call the service object. Then I'm going to make the use of the toData URI method, and I'm going to pass in the asset object again, and then close it. So this is going to return us the asset detail, and let me just, okay, this is going to be closed over here, or else get. Let me open lambda over here, and I'm going to make use of the redirect object now. Redirect dot add flash attributes, and we are going to pass in the error over here, and we're going to just pass in another message for asset not found, and I'm going to return redirect slash assets. Okay, now this is complete. I just need to add this over here, and it is closed. Let me just remove the spaces to avoid confusion. And there is one more endpoint that I need to create. It's going to be get mapping again, and I'm going to call it as assets slash id slash download. This will help us to download the file that we just loaded. So this will be of type public response entity, and it will be returning a byte array. It will be taking a byte array in response entity, and I'm going to call it as download. That makes it pretty clear. And there will be a path URL, path variable in this. This will be of type string ID. Let us pause for a second and explain what we have done in the previous endpoint. So this is going to be the detail view for us. It is going to handle the get request to assets.id slash ID. It is going to show details and preview of a single asset. So it fetches the asset by the ID and returns an optional. So if found, it adds the asset itself to the model. It adds the data URI built from the base64 string for inline preview. It returns the asset detail template. If not found, it adds the error over here and redirects back to the list page. Then we are going to create the download endpoint now. So this is going to just return service dot get. We are going to pass the ID and we are going to map it. Okay, I need to rename this later. So the byte array, and I will be calling it as bytes. Okay, I think I needed to enter over here, and this bytes is going to be initialized with service dot decode. So I'm going to rename this as I need to use it. Okay, decode the asset and then close it. And we are going to return response entity dot okay. This is going to be having a header. I think there is a typo. Okay, HTTP header dot content disposition, and there will be an attachment to this. I think I don't need to add file name. Okay, then I have to concatenate this with asset dot get file name. I think we can actually enter this, so just to make it look clear, asset dot get file name plus. Okay, I actually paused and corrected all the mistakes that were happening over here. So talking about this download endpoint, we are going to handle the get request to download the original file. So it is going to fetch the asset by ID. If found, it decodes the base64 string back into raw bytes, and it builds a response entity of byte array type with content disposition header. It tells the browser to download with the original file name, and content type header is going to set the correct MIME type, and body is going to take in the raw file bytes. If this is not found, it is going to return a 404 not found response. So now I need to add a few HTML files that I'm going to just paste and explain later. So first is going to be the assets upload.html, and I've added it over here. I'm going to save it, and then I'm going to add others. So we have added all the three HTML files. First is going to be for the upload, then second is going for list, third is going for the assets detail. Let us just build this project and see if there are any errors in this. Okay, the build was successful, so let us go ahead and test it out. So I have ran the code again after building, and in the URL localhost 8080 slash assets, you can see the list, and assets slash upload, you can upload the file, and this file will be saved in the MongoDB database assets collection. You can see that I have uploaded two files, two images, and these are successfully stored in the database. And that wraps up our use case 5 from this base64, the most known use case series. We just saw how MongoDB can store base64 encoded strings in in text fields, making it easy to handle files even when binary support isn't always available. If you found this helpful, don't forget to hit the like button, subscribe to the channel for more such content, and drop a comment mentioning how you used MongoDB in your project. You can check out the full code in my GitHub repository, which is as usual mentioned in the description below. And thanks for watching, and I'll see you in the next one.